Hi, welcome you. So I am Dr. Ezhumalai, Professor in Head, Department of Computer Science and Engineering, R.M.D.E. Engineering College, Chennai. Today we are going to discuss push-down automata in the theory of computation. Let us take one example, then get the solution for that example. Today we are going to see the design. Design a push-down automata of the language L equal A power n, B power n, when the n is greater than or equal to 0, except by the final state. This is the question what you are going to solve today. So take this language L equal A power n, B power n, where n is greater than or equal to 0. Suppose if you are assigning n equal to 0, the language, the word will be A power 0, B power 0, it is equal to epsilon. When n equal to 1, the string, what the language string will be generated, equal A power 1, B power 1, it is equal to AB. When n equal to 2, the word will be generated for this language, A power 2, B power 2 is equal AA, BB. So for any design, you should assign the value n equal to 2. So it is a minimum value to design this successfully. Let us take this language and designing the push-down automata. Push-down automata means you should know that it contains the stack along with the finite automata. The stack operation, you know, last in, first out, first in, last out. Based on this concept, we are going to design this push-down automata. Let us take the we called starting state, we called Q0. The starting state initially indicated by this one. Suppose this input, we are taking the first input A, we are assigning it to Q0. So the Q0 will be reached to, I am assigning to Q0, reached to Q0. So Q0 input is A, the stack content initially Z0 will be there. So Q0 is the starting state, input symbol A, the first input symbol A. Initially the stack content is Z0. If it is go, the A will be added into the stack. So the stack content is initially 0, Z0. After adding this input, the first input added into the stack. First input is A, it is okay. Now we go to for the second input. Okay, the Q0 is the state. Already we are giving input symbol A. The Q0 is the state, we are giving input symbol A. So already the stack content is A is there existing. Then what is output of the input of the stack means A. Already stack content initially A is added into the stack content. The top of the stack is A now. If you are adding another second input A, already existing stack content is A. If you go like this, so A will be pushed into stack again. Is the second input also added. Now suppose you are going for B. This another input is B. This is the input you are taking for the B. If you are giving Q0 B, it goes to Q1. It is a different input compared to the A. The Q0 is accepting symbol A. If you are giving input symbol B, already the stack content is there. What is the stack content means? A. So what you have to means, you have to pop one stack content from the stack. So in Q0, input symbol is B, already existing stack symbol is A. If it is so, you have to pop one symbol stack from the data. So the existing data will be pop up from the stack and goes to Q1. Now the B is considered. Now from the Q1, so already second B is there. If it is going to Q1 2, again how many B's are there? So Q1 is the state, present state. The present input is B. The stack content is A means again you have to pop the stack content from the stack. Suppose last, it is the end of the input. Suppose assume that last content is epsilon. From the Q1, if you are giving input symbol is epsilon, stack content is by initially Z0 will be there. If it is so, epsilon goes to Q2. The Q2 is to be final state. Yes, make as a double circle. So Q1 epsilon Z0 is there means again make as epsilon and Q2 will reach. So there is a possibility if is n equal to 0, input is epsilon. If it is so, the Q0 is directly reached to Q1. So what is that? Input is epsilon, stack content is Z ln. Another, what you have to do, epsilon is there in the stack, so it will be reached to directly Q1, Q2. So the Q2 is the final state, Q0 is the initial state, Q1 is the middle state. So now, what is the transition function for this PDA is first one, delta, Q0 is the starting state. We are giving input symbol A, the first one, input symbol A, stack symbol is Z0. Okay, so this derives Q0 is the reaching state, starting state is the Q0. If an input symbol is A, stack symbol is Z0. If it is so, it reaches the same state. So next state is Q0. What is there means stack will be added to A. Again, the second input, delta is the first one, is the second input. If a delta, again Q0 is the, now consider as the present state, is this input is A, already stack content is A is there in the stack. If it is so, the next state also goes to same state, Q0 along with A. So already Z is there, so A Z0 should be added here for the first content, A Z0. Already A is there in the stack, A will be added in the stack. Next, third one, the Q0 is the present state. If you are giving input to symbol B, the stack symbol is A. If it is so, output is epsilon means so pop one symbol from the stack. That is, it goes to Q1, next state is a Q1. One symbol you have to remove from the stack. This is called epsilon. So epsilon means you have to remove one symbol from the stack. That is called the second operation. Next you go for Q0, another state. Starting is Q0, delta. Q0 is there. Suppose input is 0, n equal to 0 means no input symbol at all. If epsilon is there, the stack symbol is Z0, is directly goes to where it is reached means the next state is a Q2, next state Q2 will reach, the stack symbol is empty. Okay, these are the Q0 operations. Next you go for the Q1, this is the fifth one. The Q1, what is the input and output reach means, the Q1 is a present state, delta, Q1 is a present state, input symbol is B, the stack symbol is A. If it is so, the next one is, the next state is equal to Q1, the stack is epsilon. Epsilon means the pop one symbol from the stack. So it is the next operation of the Q1. Another operation is the sixth one. Q1 is the present state. So Q1, the input symbol is epsilon, the stack symbol is Z0, the outcome is goes to Q2, the next state is called as a Q2, so exit, pop, epsilon is the output. So these are the transaction of this design. So when the language L equal A power n, B power n, where n greater than or equal to 0, this is the design of the PDA, this is the transaction of the PDA. Let us see one example. So this, take this A power 2, B power 2, actually input is AA, BB followed by epsilon. Okay, let us take this example. So the starting state of the stack is PDA is Q0. Let us, I am going to give the Q0 is the starting state. Actual input is what I am giving, A power 2, B power 2, that is called AA, BB. Initially the stack contains Z0. If it is so, what is the next transaction means? That is, Q0 is present state, present input is A, the stack symbol, third content is stack symbol is Z0. What is the transaction? Q0 is the input symbol A, stack content is Z0 means this is the next operation. It goes to Q0. What is the stack content? A will be added into the, A will be pushed into the stack. So this will be remaining input is A, B, B. This A will be pushed into the stack Z0. Already Z0 is existing, A will be pushed into the stack. Now the remaining symbol is, now present state is a Q0. The first input of the remaining input is A. So Q0 is the state, the remaining input symbol is A, and the top of the stack contains A. This is a present input, this is a present stack content, this is a current state. So Q0 input A, stack A. So Q0 is the input A, stack symbol is A. If it is so, the next outcome is it goes to Q0 only. So A will be pushed into the stack. So here the remaining rest of this input symbol is BB. This A will be added into the stack. Again AA, Z0 will be there in the stack. Okay. Now, so Q0 is the present state. This is B is the present input. The stack content is A. If it is so, see that Q0 is the present state, B is the present input, stack content is A. If it is so, what happens means it will goes to Q1. The next state will be Q1. What to do? So it will be epsilon. Epsilon symbols, one symbol you have to remove from the stack. That is, when the present input is readed, so remaining input available is B. One symbol you have to remove from the stack. That is called epsilon. Okay. One symbol you have removed from the stack means remaining available is A, Z0. Similarly, again Q1 is the input symbol, present state. B is the input symbol, stack symbol is A. Q1, B is the present symbol, stack symbol is A. What is the transaction? Q1, present input is B, stack symbol is A. Similarly, so it goes to Q1, present state is a Q1. Here remaining input is available epsilon, input is consumed now. Remaining input is available epsilon. So the outcome of this stack is epsilon symbol. Oh, remove one symbol from the stack. So this here also removed from the stack. Z0 is available in the stack alone. Now another thing. So Q1 is the present state Q1. Q1 is the present state. Input is epsilon. Z0 is the stack content. See the content. Q1 is the present state. Input is epsilon. Stack content is Z0. If it is so, it will goes to Q2. The next state will be Q2. Epsilon means remove one symbol from the stack. The stack is empty now. Nothing will be removed. Z0 is by default available in the stack. So the current state. So present all the inputs are consumed. So we reach to Q now. Q2 is the final state. So we consider the present input is accepted. Now suppose you are giving the current input W equal AA, BB, BB. Okay, N equal to, first A equal to B equal to 3 means this input is not accepted as per our design. Now, this is the sample example. If inputs A and B are equal, so whatever how many numbers of A and B, so our system will be accepted. This is a design for A power n, B power n, when n greater than or equal to 0. So this imbalance of A and B is not accepted. Once again you can check this similarly the same way. Okay, thank you for watching this video.